All right, so I'm going to talk briefly about how to drive on walls, basically how to implement hover physics in cars without needing to understand all the crazy math or anything that goes on behind it, because it's actually not that tough. Okay, so it's not that scary. First thing is we're going to replace gravity. Then we're going to match gravity to the surface that we're on. Then we're going to push off that surface, and then we're going to drive, and not necessarily in that order. Okay, so you have a physics object in your game, and you start it, and everything just falls, lands on the ground, done. Okay, so first thing is we turn off gravity. Now there's two places you can turn off gravity. You can turn off globally for the entire scene, and that's your choice if that's how you want to run the level. Or you can turn it off per object. So on the rigid body or physics object, I don't know exactly what to call it in Unreal. I'm starting to get into Unreal now. But anyway, we just disable gravity on those. So great, now the object floats. Okay, so now we want to replace gravity. This is not an accurate representation of gravity, but it's close, especially for a car that's traveling close to the surface of the ground. So gravity is 9.81 meters per second, or in Unreal, it's 981 centimeters per second. And you're going to multiply that by your down vector. So things go down. And then you're going to multiply that by delta time. Now, you would do this in a slightly different way, similar with a lot of the other physics that I'm going to represent. These are shortcuts to get you started quickly. Okay, so now gravity works, you're back on the ground again. All right, so hover thruster. What goes down must come up. So first off, we're going to ray cast or line cast down for the distance. So we just figure out how far is it from us to whatever's beneath us. And we establish a power level from that. We say maximum distance. So if it's 3 meters or 5 meters or 1 meter, we're going to divide whatever our distance was by that maximum distance. That'll give us a number between 0 and 1. Now, as we're closer to the ground, it's going to be 0, so we want to reverse this. We're going to do 1 minus whatever we get from that. So as we're closer to the ground, that means our power level is going to be wanting to put more force into pushing us back up. Okay, so now what is an appropriate force on this? That's hard to say. If you get into the physics and you start adding forces, you're going to find that sometimes the numbers need to be wild. So it doesn't need to be 981, does it need to be 10,000, a billion? Don't be afraid to try numbers. A lot of times you try getting into this and the first time nothing happens, and it's literally because you just don't have enough force. And it changes because of the mass of the object that you're trying to move. Okay, so now in the game, there's going to be 4 hover thrusters based on this particular concept. So each one is an engine location where the tires would have been. And so we're going to be using add force at location. We're adding force to the car object, to that single main object, but we're adding it at the location of the engine. That does not need to be a space within the physical boundaries of the mesh that you're working with. It can be just outside it. Now, when you first run this, it's going to wobble and bounce. So we need to stabilize it, and that's really easy by putting in drag, angular drag or drag, and then linear damping or angular damping. And that's basically so it doesn't rotate much, it stabilizes as it rotates, or as it's moving and you take off the gas pedal, then it starts to come to a stop. Okay, so we still just float. All right, or we're back up to floating again. So now we want to add force. That's really easy. We just add force and just figure out how much force you want to apply to make the vehicle go forward. To turn, it's add torque. And you use the vector up, and positive will go one direction, negative will go the other. I don't know which way it's going to be in which system. I almost never know my left from right. So, all right, last part of this is going to be hovering on walls. So one of the things that as I first started getting into making the racing game here, I just wanted to be able to drive on walls on corners and not just like crash the car on corners. But once I got it going, I decided I'd just change the gravity completely. So what we do is we have a gravity normal. Rather than using down, just literally vector.down, we're going to create a vector 3 that holds on to whatever normal direction we're supposed to go. If you're not familiar with normals, they're actually really easy. I would recommend just go take a look. But it's basically 1 meter in a particular direction with a vector 3. Okay, so we get the normal of the surface. So when we did our line cast or our ray cast down, we get our up, we get whatever it's saying is up, and so that's now our gravity. Technically, we need to negative it because it's going up and we want the force to go down. All right. Now, in the real games, once you start doing this, there is a lot more to this. Like each one of the corner engines on mine has 7 different sets of thrusters, and debugging is going to be one of your best friends in this, having the debug lines, because trying to debug what's going on with a physics direction, sometimes you move an angle here, and all of a sudden everything goes that way. And it's hard to debug without the lines. All right. And I'm going to be posting a longer version of this where I actually go into details of the exact math and the real structures of getting it going in both Unreal and Unity. That should be coming in the next week or two. And otherwise, you can connect to me on here, and I am available for a couple of questions.